All right, guys, here we are. We are going to do states of matter. So we're going to talk a little bit more about the different states of matter. So we are in the Chapter 8 notes. If you scroll down for this to slide 14, we're going to talk about the phases of matter and then phase changes. So please make sure that you pause whenever you need to. So you can write everything down, write all the good terminology, vocabulary that you need to have down. All right, on Earth, this is phases of matter. On Earth, pure substances are usually found as solids, liquids, or gases. So most commonly on the Earth, we have those three states of matter. There are four phases of matter, four states of matter. We'll talk about the last one, but these are the ones that are most commonly found on the Earth. These are called phases. For example, of course, if you have solid ice cubes in a glass of tea, you have liquids and solids together, and then of course the air that we're sitting in right now is a gas. Let's see. All right, solids hold their shape. They do not flow, so the particles are not able to move past each other in a solid. Molecules in a solid vibrate in place, but on average don't move far from their places. So within a solid, the particles are moving. They're not staying still. But they're vibrating, and they are stuck in that position for the most part. They are not able to move from one place to another. So you're not actually going to see this atom move somewhere else down here ever. They're stuck in that particular structure, even though they're slightly vibrating in place. Liquids hold their particular volume. You can't compress a liquid into a smaller volume, but it doesn't hold a shape. And the reason why is because liquids flow. The particles move around each other. So you may have an atom right here within a liquid that after some time will flow over to a different place. Okay, and these particles are able to move past each other. Therefore, that's what makes liquids different than solids. So that's the difference between solids and liquids. Gases are a little step past that. They flow like liquids do. The particles are able to move past each other, but they also have a volume that can change. So gases will expand to fill their container, or they can be compressed into smaller containers. A gas does not hold its own shape or its own volume. So gases will flow into other areas. Molecules in a gas have enough energy to completely break away from each other. So liquids don't break away from each other often anyways. They're not going to totally separate. But with gases, those particles are able to separate from each other. So this particle is completely capable of separating from another particle that it is near. And they flow just like liquids do. And so this is a picture, probably a good idea to draw that picture. Solids, very structured and rigid. Liquids, pretty close together still, but are able to flow around each other. If you spill a glass of water, the liquid's going to flow out of the container. And then gases, particles are very spread very far apart, and they're able to flow around each other. When they are close together, molecules are attracted through what are called intermolecular forces. So, for example, water molecules are attracted to other water molecules. This is going to move on by what's called intermolecular forces. So this molecule of water is attracted to this molecule of water by a force called an intermolecular force. And this molecule of water is attracted to this molecule of water. And so that's what holds water together. It holds them in liquid form, and it also holds them in solid form in their particular structure. All right, what is freezing point? So freezing point is the temperature at which a substance changes from a liquid to a solid. So think about when something freezes, like water freezes. It's that temperature in which the liquid is changing into a solid. I'm always messing up my picture here. All right, melting point. Again, melting then is the same as the freezing point, but just the opposite the opposite flow of things. So melting point is the temperature at which a substance changes, and think what melting is, from a solid to a liquid. So melting point and freezing point are actually the same thing, not freezing point. Freezing point. Melting point and freezing point are the same thing, okay? For most substances, I can't think of anything that it's not the same. So the melting point of water, 0 degrees Celsius or 32 degrees Fahrenheit, that is also the point at which it freezes. All right, in terms of boiling, hopefully you know what boiling is. Think about the phases that are changing, what's changing into what whenever we're boiling. So the boiling point is the temperature in which a liquid becomes a gas. So liquids changing into gases at the point of boiling. And for water, this is for H2O, the boiling point is 100 degrees Celsius or 212 degrees Fahrenheit. We obviously use Fahrenheit a lot more. We're familiar with Fahrenheit because that's what we measure, like the temperature outside. But in the world of science, Celsius is what's used most commonly. So 100 degrees Celsius is the boiling point of water, and 0 degrees Celsius is the freezing or melting point of water. All right, so this is just to kind of give you an idea of different materials and their range of freezing points or melting points and boiling points. Materials have a wide range of melting and boiling points. So it's a kind of a good idea to think about this in terms of what we know as normal temperature. So just to give you an idea in Celsius, because that's not something we're used to. Like you may be used to saying like, oh, the temperature of my house, my mom keeps the temperature at 67 degrees Fahrenheit in the winter or 70 degrees Fahrenheit. That's a common number to us, but you may not know what that is in Celsius. So the normal temperature of a room is about 20 to 23 degrees Celsius in the wintertime, I would say. So that kind of gives you an idea. If the room is about 20 degrees Celsius, that's what feels comfortable for our bodies to be in, about 70 degrees. So with that said, you think about how low these melting and boiling points are for helium. So much lower than normal room temperature means that helium is what state of matter at room temperature? Well, of course, it's a gas because it has to get really, really cold to become a liquid or a solid. And if we jump down to something like aluminum, think about aluminum foil, right? Foil that you use to cover your food with. Look how high its melting point and its boiling point is. So what does that mean? That it doesn't melt until the aluminum gets to 660 degrees Celsius. Normal room temperature can get as high as 23 degrees Celsius. So we would have to heat that aluminum up really, really high to get it to even melt from a solid piece of aluminum in order to get it to change to the liquid phase. And then to boil it, wow, that would be even higher. So this kind of puts some things in perspective as far as some different substances that are around us. All right, so vaporization. So there are two phase changes, vaporization and condensation, that are kind of the reverse of each other. Vaporization is when a object changes from a liquid to a gas. This is kind of the same thing as boiling. We're going to put that in here. Boiling and vaporization are the same thing. This is kind of like the scientific term of that process. Vaporization, the energy required to change a liquid at its boiling point into a gas. Substance changing phase from liquid to a gas, just as we said. All right, and then opposite of that is condensation. And condensation is when a substance changes phases from a gas to a liquid. So you've probably seen condensation on the back of, or on a glass, a cold glass that's sitting out. It's taking the gas that's in the air and it's putting it into a liquid form on the outside of the cup. Or maybe you see condensation on your bathroom mirror whenever you get out of the shower. That's because the gas particles are condensing and becoming a liquid on the mirror. All right, and then another phase change, this is a less common one to us, but it does exist in the world, is something called sublimation. And sublimation is when an object or a substance changes from a solid into a gas phase without going into a liquid first, which again doesn't happen very often, because if we see an ice cube like H2O, we know that for an ice cube to turn into a gas, it would have to go to liquid water first and then turn into gas particles. But this is not what sublimation is. Sublimation is when an object is a solid, like iodine, and then instead of melting into a liquid first and then turning into a gas, it goes straight from the solid to the gas phase. So an object that sublimes would be like iodine. Another object that sublimes is mothballs. If you know what mothballs are, probably nobody does anymore, but they're little pellets that you put into your drawer and to keep the moths away. And instead of melting into a liquid first, the mothballs turn straight into a gas, and the gas keeps the moths away so they don't eat your sweaters in the middle of winter. Oh, I just wrote all over that. Okay, the process is called sublimation. Sorry about that, guys. And then the opposite of sublimation is a process called deposition. So instead of going from a solid straight to a gas, gases can go straight to a solid without changing to the liquid phase first. So if you have a gas, and instead of turning into a liquid and then into a solid, it goes straight to the solid phase, this is called deposition. And the most common example of this process is snowflakes. This is why snowflakes form the way they do, is because up in the atmosphere, gas turns straight into a solid, and then snowflakes form those crystals. Instead of turning into liquid, if it turned into liquid, we would get rain or sleet. Instead, it turns straight into a solid, and we get snowflakes. So this is what you're always hoping will come in the wintertime, or maybe you're not hoping. Deposition happens and we don't get any snow at all.
Your attention, please. At this time, all students remaining in the building should report to the commons area for lunch and a quiet study hall afterwards. Unless you are with a staff member, then that student can stay with that staff member in their classroom. Thank you.
All right, and then the last phase, so we said solid, liquid, and gas were the three phases that are most common on the Earth that we see. So we notice solids, liquids, and gases, but there is a fourth phase of matter. It's called plasma. Plasma is a phase that involves the ionized electrons on atoms. The sun is made up of plasma. Of course, a lot of things in the universe are made up of plasma. Plasma, if you've ever seen, well, plasma exists whenever lightning strikes too. The air is ionized by lightning, and the bright lights that you see whenever a lightning bolt comes down, it's creating plasma. So it does happen on the Earth. It's just not quite as common as our other three phases of matter. All right, so here's kind of a flow chart I would suggest looking at. So it has our solid, liquid, and gas. It's important to note this intermolecular forces here. I'm not able to draw on that. The intermolecular forces do get stronger from gas to liquid to solid. So they are the strongest within solids, and they are the weakest within gases. That's why gas particles are able to come apart as they are, and why solids are held together. As far as temperature goes, though, and this should make sense to you over here, when it comes to temperature, the coldest temperatures are solids, and then as temperature increases, an object becomes a liquid, increases more, becomes a gas, and then of course plasma has the highest temperatures of things, which makes sense if you think about the temperature of the sun. And then one last thing, this is a great diagram. I would suggest putting this in your notes. These are the three most common phases: solid, liquid, and gas, and these are the processes that we talked about. We talked about freezing and melting, vaporization and condensation, and sublimation and deposition. And so whether you're going from a solid to a gas, that's sublimation. If you're going from a gas to a solid, that's deposition. So this is a really good flow chart to put into your notes on if you're changing from one phase to another phase. Well, what is that called? If I'm changing from a solid to a liquid, that's called melting. If I'm going from a liquid to a solid, that's called freezing. So please copy that down into your notes. All right. See you guys later.